Hi, so we're back, and this video is still on lesson 6 in your booklet. Okay, and there is another rule here. Okay, it says the number of different ways that n letters can be arranged where m1 of the letters is identical and m2 is identical, and so on is given by that formula there. Okay, I know this might be a bit difficult to understand right now, but when you go through an example, then hopefully it's going to be easy for you guys to understand what's going on here. Okay, so let's just go through an example. Letter arrangements where we have repeated letters. Okay, so like this word here that is needed. Okay, so you can see it's got 3 E's, it's got 2 D's there. So you got E's and D's that are repeating each other there. Okay, so if we're gonna just do our 6 factorial, we're just gonna think that so if we do that, we're gonna find that we're gonna have a lot of similar words. Now, this rule is to eliminate all those similar words, or let's just call them duplicates, all those unnecessary duplicates. Okay, so now let's just go through the examples. So the first one, how many word arrangements can be made with this word if the repeated letters are treated as different letters? Okay, you kind of know how that works, right? This 1, 2, 3, 4, 5, 6 letters there, so it's just 6 factorial, which is equal to, okay. All right, so let's see. I would like to put my calculator on this so that you can see exactly how this works. So 6 factorial, and that's 720 ways. Okay, if we treat these as different letters, now in those 720 word arrangements, you're going to find that there are going to be a lot of duplications there. Okay, now how do we take care of the duplications? Right, let's see in the next examples how this is going to work. Okay, so how many word arrangements can be made with this word if the repeated letters are treated as identical? Okay, now this is where we're gonna use our rule, right? So our rule here is n factorial over m1 factorial by m2 factorial by, and it goes on and on. Okay, so how many words do we have? We have 6 letters, sorry, 6 characters in this word. Right. What letters do we got? Well, we've got n. Okay, so there's only one n there, so that's gonna be 1 factorial. How many other letters do we have? We've got e, but we've got 1, 2, 3 e's. Okay, so we're gonna say 3 factorial. Okay, remember if I say 1 factorial, 3 factorial, it means they're multiplying each other. Okay, and how many d's do we have? We've got 2 d's there, so that's gonna be 2 factorial. Okay, so let's just take our calculator, calculate that quickly. Okay. I think you could see. I hope you've written that down already, because I'm gonna do this on the calculator now. Okay, so on the top we're gonna put 6 factorial. On the bottom we're gonna put 1 factorial. Okay, let's just do this to be sure. By 3 factorial by 2 factorial. Okay, so that's 60 different arrangements, right? So we're gonna write 60 arrangements. Okay, the 60 arrangements that can result from this. Okay, what next do we have to find? Let's see. How many word arrangements can be made if the word starts and ends with the same letter? Let me just write that word over here quickly so that we don't lose track of what we are doing. Okay, all right, so see how many word arrangements can be made with this word if it starts with and ends with the same letter. Okay, two possible scenarios for that. Either one is going to start with an E, then we have 1, 2, 3, 4, and end with an E. The other scenario is where it can start with a D and end with a D. Now let's see how many arrangements can we get with each scenario. Okay, so it's this or that. Remember, these events are independent, so whenever we have or, we can just add, and whenever we have and, we can just multiply, because these are already mutually exclusive events. Okay, these are things that can't happen at the same time, right? So how many arrangements are we gonna get? So if I start with E and I end with E, that means I've already taken 1 out and 2 out, so I'm left with 1, 2, 3, 4 there, right? So now the question is how many, right? So in the first arrangement, we're gonna have what? 4 factorial. Why 4? Because the 2 letters I've taken out already. Okay, so I can only work with 4 letters over. Well, how many n's do we have? We've got 1 n times how many e's is left there? 1 e is left. And how many d's do we have? We've got 2 d's there. Okay, right, so let's calculate this quickly on the calculator. All right, so let's do that. Fraction 4 factorial over 1 factorial by 1 factorial by 2 factorial. Okay, so that's 12 different ways. Okay, that's the first scenario. The other scenario that we have is if we're going to start with the letter D and end with the letter D. Okay, let's go back to our words. That means this is out and that's out. So we left with these. Okay, we left with 4 letters actually, right? So we're going to say 4 factorial over, right, how many E's do we have? We've got 3 E's there. How many n's do we have? We've got 1 n. Can't have d's because we've used them at the ends of the words. Okay, so that's why we're not gonna include that. Okay, so let's calculate that. Right. Okay, let's go like that. Okay, so fraction 4 factorial over 3 factorial times 1 factorial. Okay, and that's equal to 4. Okay, don't mind the skewness of the page. As long as you can see what I'm doing there, I think that's what's most important. Okay, so now the final answer, mainly it's this or that, and this is mutually exclusive, so we can just add. Okay, so now the total is just going to be that 12 that we got there plus that 4 that we got there, and this is 16 different ways. Okay, right? So that's what you can do. Let's see, do we still have anything? Oh, we're done. Okay, so that is how you work out the solutions to these questions. These exercises at the next page, on page 19. Please do those exercises and good luck with that. Thank you.